Okay. One thing that's important to always question at the beginning of any perms and commas question is, does order matter or does it not matter? Okay. Can you guys tell me when order matters? Perms or commas? Perms. Good. Okay. And it doesn't matter with combinations. Just a little review before we get into the questions here. So just a reminder, the fundamental counting principle, you're looking at the number of ways or possible outcomes, I guess, or pieces to a toy, or like you saw in your quiz there, number of different ways to order a car. So what type of car, what color, and then the finishing touches maybe. So you just multiply the number of ways by each other. Okay, or you could use factorial notation. So n factorial, that's when you're looking at, say for example you had a 5-letter word, but you only need to take 3 of those letters, then it would be 5. So that wouldn't work for factorial notation. Let's just say we had a 5-letter word, you need to take all 5 at a time. Okay, so it would be 5 times 4 times 3 times 2 times 1. Multiplying those together, we get 5 factorial. Permutations in factorial notation is given by n factorial over n minus r factorial. Okay, that's n pick r at a time. And permutations, when you see repetition, don't forget to divide by that repetition. So I don't know if everyone was here for that cereal box example, but we had to divide by the number of Raisin Brands that were repeated. Or, for example, in specific words, we would divide by the repeated letters. Okay, and then lastly, what we've covered was combinations. So n choose r, we get n factorial over n minus r factorial times r factorial. Okay, I'm going to get you guys to get started on example number 1 and decide perms or commas first. Hi, Cynthia. Okay, no problem. Is it urgent or? Oh, okay, sounds good. Thanks. You guys gotta go. Oh. Alright, so how many arrangements of the word poppies can be made under each of the following conditions? So first one, no restrictions at all. So let's take a look at how many letters we have. 1, 2, 3, 4, 5, 6, 7 letters. Okay, so without restrictions, I'm going to use the fundamental counting principle to start. For the first letter, I have 7 choices of letters, correct? And then 6, and then 5, and then 4, and then 3, and then 2, and then 1. That's equal to 7 factorial. Okay, or 7 pick 7. Do I have any letters that repeat though? Which one? P, and how many times does it repeat? I have 3 P's that repeat. Okay, so that means you have to take your answer from here and divide it by 3 factorial. So anytime you see a repeat, you have to divide by what repeats and how many times. So if you guys just help me out, 7 factorial divided by 3 factorial. 7 times 6 times 5 times 4 is? 840. Okay, or you could just put 7 factorial divided by 3 factorial. Alright, part B. If each arrangement begins with the letter P. So 1, 2, 3, 4, 5, 6, 7 spaces. The first space must be occupied by a P. So I only have one choice. It has to be a P. Okay, and then I have 6 letters left. So 6, 5, 4, 3, 2, 1, which gives me 6 factorial. But I have to recall that we started with 3 P's, we've used up 1, so within these letters there's still a repetition of 2 P's. Okay, so I've got to divide by 2 factorial. And when we calculate that, we should get 360. part C, the first two letters are P. So we have P, P, and then 5 letters left. So if the first letter has to be P, we have one choice. If the second letter has to be P, we have one choice. And we've used up 2 letters, so we have 5, 4, 3, 2, 1 choices left. Right, so that's equal to 5 factorial. Do I need to divide by any repetition? No. Okay, because nothing repeats here. And if you're asking, well, isn't it PP, so that repeats? Don't get confused by that, because they're telling us the first 2 letters has to be P, so there's only one choice. It's only when you're dealing with multiple arrangements that you have to worry about dividing by the repeats. Okay, next one. If all the P's are to be together. So let's just say we put P, 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 and then we have 1, 2, 3, 4 letters left. So for P, 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 1, 1, and 1. And then I have 4 choices, 3, then 2, then 1. So that's equal to 4 factorial. But truthfully, the answer is 5 factorial. Why? We've done a question like this before. 5 spots, good. Is that what you're going to say, Dawson? Okay, good. So in this last example, it said the first 2 letters had to be P. But here it just says...
Excuse interruption. Could all junior Skill Academy students please come to the office?
Okay, so here it says if all the P's are together. Well, the P's could be together in that first spot, or the P's could be together in the second spot, or the P's could be together in the third spot, or they could be together in the fourth spot. Oops. Or they could be together in the fifth spot. So how many different ways could P be together? 5 different ways. So what's 4 factorial times 5? It's 5 factorial. Good. Okay, so rather than having to draw out all these scenarios, what you could realize is that this can go into 5 different spaces. And how do you know that? 1, 2, 3, 4, 5. Okay, so this is actually equal to 5 factorial, which is equal to 120. I'm sorry, I should have put 120 here as well. Alright, next example. The first letter is P, the next one is not P. So we have P, not P. And then 1, 2, 3, 4, 5. Alright, so if the first letter is P, that's one choice. If it's not P, what other letters could it be? Think about poppies.
4.
So O, I, E, or S. So there's 4 choices there. And then any other restrictions? No. So how many letters do I have left? 5. 4, 3, 2, 1. Okay, so 4 times 5 factorial. So we know 5 factorial is 120. 120 times 4 is 480. What have I forgotten? Look at the word poppies. We have a P, then not a P.
Oh, repeat.
The repeat, good job. Okay, there could still be 2 P's here. So because they're repeating, we have to divide by 2 factorial. So our answer is 240. Good job, Hannah. You have fire. So you can't be sleeping with these types of questions. You have to be thinking always. If there's a repetition, are you using perms and cons? So no sleeping here. Let's read through the next example and we'll figure out, is it a permutation or a combination that we're going to use? Alright, so a class consists of 5 girls and 7 boys. A committee is to be formed consisting of 2 girls and 3 boys. Determine the number of ways a teacher can choose the committee if there are no further restrictions, Johnny's on the committee, or the twins cannot both be on the committee. Okay, before we get to the specifics, let's decide. I'm going to choose a committee from this class. It says that I need how many girls? 2 girls. So I'm going to choose Jane, and I'm going to choose Emily. Sorry, girls, you're cut. Okay, you guys are on the committee. Does it matter that I picked Jane first?
Like it hurts my hands.
Okay, well, I'll pick you first then. Does it matter that I picked you first?
I know.
Well, you're both on the team, so do you feel good about that? Okay, the order of how I pick you guys doesn't matter. I've picked you guys both at the same time, let's say. Now you both feel great. Alright, so does order matter? No. So I'm going to be thinking in combinations here. So if there's no further restrictions, then out of the girls, I have 5 girls, and I need to take 2 of them. So we're going to go 5, choose 2. And out of the boys, there's 7 boys in total. I'm going to take 3 of them. So 7, choose 3. Then we just multiply that out, see what we get. You waiting on me? You gotta practice how to do this? So just to verify, you should get 350. Make sure you do. Did you do it?
Yeah.
Oh, good job. All right, next one. Johnny, the principal's son, has to be on the committee. So for Johnny, okay, imagine we're talking in terms of combinations, or I have to do a choose. Hey, how many Johnnies are there? How many Johnnies will I choose?
Just one.
Just one. Okay. 1 choose 1, it's just equal to 1. There's only one choice, Johnny. Okay, so you don't actually have to show this step, but I just wanted to explain of all the Johnnies, we're choosing one of them. Now let's do the girls. Okay, how many girls?
5,
How many am I picking?
2,
2. Now boys, how many boys?
6.
Oh, you're thinking. Good, I like it. So we had 7 boys, but now we've taken Johnny out of the picture. So there's actually only 6 boys to choose from. And
2.
Johnny's already on the committee.
Whoa, calm
So
down.
if we've taken 1 boy and we need 3, we only need 2 more.
Oh, so it's still
So 6 choose 2. Because we've already taken 1 boy. So we only need 2 more.
So 150.
What did you guys get?
150.
Excellent.
Again. Yeah, we got that too.
Alright. Next one we can solve in 2 ways, but I'm going to just solve it in the easiest way. Alright, the twins, Peter and Paul, they cannot both be on the committee. So the first case would be Paul, but not Peter. Or Peter,
Emily, come on.
but not Paul. You guys all right over there?
Did you have like the landed on my pencil.
No, she can't. No, you gotta go from the side. The side's easier. There you go.
Or like your finger, do that too.
No.
I'll just wait. Don't worry.
Hey, Emily, how are you? God, so easy.
These are so video.
Just keep it away. I'm sorry.
Snaps it.
Okay, go back. So you're ready?
Everyone has to watch your video for home one.
All right. The first scenario is we take Paul but not Peter because they can't both be on the committee, or we could take Peter but not Paul, or neither. What does or mean again? Add. Very good. Okay, so if we take Paul, how many Pauls do we have? One, choose one. Okay, now let's look at girls. Does taking Paul affect how we're going to choose the girls?
No.
No, we have 5 girls. We need to take 2 of them. Okay, and now I need the boys. How many boys?
6.
Nope, 5.
5.
Jared's got it, 5. Because we have to take Paul, but Peter can't be on the committee. So we're taking away 2 guys from the scenario. So we have 5 guys. We need to pick 2 of them. Okay, and as you guys said, the or means we're adding. Okay, now Peter's on the team, but not Paul. Does the scenario change from taking Paul or Peter? No, so we're just writing the exact same thing. 1, choose 1. And guys, don't waste your time by calculating 1, choose 1. It equals 1, okay? So you don't have to actually calculate it. Okay, and then 5, choose 2, and 5, choose 2. Okay, or, so we're adding. Neither Paul or Peter. Okay, well, we have Paul and Peter. We're taking none of them. Girls, 5, choose 2. Boys? 5, choose 3. Good. Alright, now we just calculate that. See what we get. So you get 300.
Yeah, we got that. This is what she does. Like,
Hey, no making fun.
she just plugs the number in her calculator. She's like, yeah, I got it.
Like you just put.
Like, yeah, so.
Oh, literally
you
just put 300?
She put 300 in her calculator.
You're like, got it.
Press enter. And presses enter too.
Alright, so that's a strategy that might not help on the diploma, but something that will help on the diploma is more exposure to questions like this. So, guaranteed you're probably going to see a question. I don't know which topic it's going to be on, but they're going to show you students' work, and you're going to have to figure out the errors from that work. So here there's 3 students who they all made mistakes. We're going to dissect what they've done and see how we can correct it, okay, what errors they made. So let's read through this. David, Stephen, Helen, they're all trying to answer the following homework question. The students in a school band have practiced 5 popular and 6 classical music compositions. For the school concert, they will choose a program consisting of 3 popular and 2 classical music compositions. If the order of the compositions matters, determine the number of different programs which can be presented. So David decided to go 11 pick 5, permutation. Stephen decided to use permutations as well, 5 pick 3, 6 pick 2. And Helen went using combinations, 5 choose 3, and 6 choose 2. Each student was convinced they were right, but they're all wrong in some way. So I want you guys to just take a moment, take a look at the question that's given, then take a look at the work that's provided from each student, and rule out why they were wrong. Okay? So figure out why they were wrong. Take a look at the information given and the numbers that they came up with, and what assumptions maybe David and Stephen and Helen made.
No, they're all wrong. You're right.
It works that way. He's wrong too, though.
No, if he like, you gotta change it to then like choosing five over the one, like hunting by five.
You're what?
Having five.
Okay, any errors you guys see in David's work?
Yeah.
What?
Like he picked like all five of the total, but you can only have three popular. Like three out of the five have to be popular, and two out of the six have to be classical. So we should have done like 5P or 3P5 or 5P3 and 6P2 instead of like what you
That's
did. Like
wrong.
Well, that's what Stephen
I
did.
know, but then you need to like times it by something else as well. Like I think.
You're on the right track. There's an error in your work too, but we can talk about that
Okay,
later
yeah,
as
that
well.
was his error.
Okay, let's just look at where does David get the 11? Okay, 6 popular and, 6 classical and 5 popular compositions. So that's where he's getting the 11. Okay, because that's what they've practiced. And then he took the 3 popular and 2 classical music compositions that need to be in the program. So of the 11, he's thinking, well, you've just got to pick 5 of them. But we need 3 popular and we need 2 classical. So basically he's assuming we can take any composition, any 5 compositions. Rather than 3 pop and 2 class. Okay, so he didn't specify that we took 3 popular and 2 classical compositions. He just took 5 out of the whole group. So it could have been 5 popular songs, but is that in the school program? No, we need 3 popular, 2 classical. So Dave's made the assumption that he could just take any of them, really. You wondering what something says?
I didn't know that like pop stood for popular.
Well, I just put it on the board. I don't know if it actually.
But like then she said pop culture. Is that
I guess
popular
it, yeah, it
culture,
would be
so
popular
it's-
culture. Or like pop music. I'm pretty sure
Yeah.
it's popular music.
Why did you think it was like a great question?
No, I just like thought it was just like a word.
It's not a soda.
Because it sounds like spongy.
All right. So this is where you were, hey Chris?
Yeah.
So you were thinking
Could you
5 pick 3, 6 pick 2?
you have to times it by like you'd have to times it by like that order matters what you pick too, right?
I might just kind of write out what Stephen has assumed for you guys. So using the fundamental counting principle, he's done 5, 4, 3, and then multiplying that by, oh, you're only allowed 2 classical, so he had 6 classical to choose from, and then 5 classical to choose from. So that's the calculation Steve's done. Stephen. But he's assuming that the classical and the popular music need to be played consecutively. So that it needs to go, what is it, 5? That was popular first. So he's assuming that popular needs to be played, boom, 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 and then classical needs to be played. But that's not necessarily the case. We need the total number of ways that we could select the songs and then play them. Okay, so this was for pop. You learn culture, songs. And this is for classical. Okay, so what Stephen's assuming is that pop songs are played consecutively, or one after another. and then classical songs are 2. Or you could write it full out. Classical songs are also played out consecutively. Now let's talk about Helen. Alright, I'm going to point out one important thing that we haven't really spoken about. It says, if the order of the composition matters, what was wrong with Helen's calculation? She did combinations, so she assumed order didn't matter. Well, I am going to tell you that Helen is the closest. Yep. So working off of Helen's work here, she's missing one piece. She's assumed the order hasn't mattered, but she has done her selections appropriately. Of the 5 popular songs, she's chosen 3. Okay? Of the 6 classical songs, she's chosen 2. But are they in order? So how could I take these selections and put them in order? Multiply by 5 factorial. Because we have 5 songs, and we need to, first, of the 3 and the 2 that we've now picked, we have 5 choices at the start, then 4, then 3, then 2, then 1. Okay, so the correct answer will be, solution, will be 5, choose 3 for our popular, and then 6, choose 2 for our classical, and then we need to multiply by 5 factorial for the order. And if we calculate that, there's 18,000 different ways we could select a program for your school band. Do you think the composer or the band teacher is going to think about every scenario?
I think so.
Maybe. Or maybe they'll just do it more free-flowing and artistically. Alright, so as you guys can see, some questions you have to think about combinations combined with permutations.